notice, and this is a typical copyright. We continue with the 2018-2027 CSEC mathematics syllabus. Schedule of videos. This is just a reminder. By the end of this month, September 2024, I'm hoping to have all 32 videos completed and uploaded from section 1. Then next month, consumer arithmetic. That would be October 2024. Maybe 13 to 15 videos, and so on by November, December. In January 2025, should be at statistics, and then algebra in February, March, relations, functions, and graphs, and so on. Hopefully by May, early May, or even late April, I will have the complete set of videos uploaded. As I said, from section 1, I have divided that into 32 videos, all of which will be made available in their entirety on YouTube. So 32 videos. Right now we are here at video 8, where we have to do some preliminary concepts, some prerequisites, in order to add, subtract, multiply, and divide fractions. And then once we finish video 8, we go to video 9, where we will actually add, subtract, multiply, and divide fractions. So, still on objective 3, section 1, evaluate numerical expressions using any of the 4 basic operations on real numbers: addition, subtraction, multiplication, and division of whole numbers. We did that already. Decimals, we did that already. Now we are at fractions, and we will do that in 2 parts: a preliminary section followed by the actual addition, subtraction, multiplication, and division of fractions. What you see up here is a print screen from the actual CSEC syllabus. While I had initially intended to do 4 videos from this section: whole numbers, decimals, and then fractions, that would be 3, and lastly, order of operations. This 3rd section here has to be divided into 2 parts. This current video deals with concepts relating to fractions, and then the next video, which would be 3B, we will actually add, subtract, multiply, and divide fractions. So in the last video, which was this, we added, subtract, multiply, and divide decimals. Now we will deal with some concepts relating to fractions before we actually add, subtract, multiply, and divide fractions. So what is a fraction? Now here is one definition. Fractions represent the parts of a whole or a collection of objects. A fraction has 2 parts. The number on the top of the line is called the numerator. It tells how many equal parts of the whole or collection are taken. The number below the line is called the denominator. It shows the total number of equal parts the whole is divided into, or the total number of the same objects in a collection. If I have a plyboard like that, and I divide it in 2 like this, then I now have 2 equal parts. So I can write the denominator as 2. And if I consider one of those parts, let's say I painted this top part blue, then I have painted 1 out of 2 parts blue. So what I have painted is 1/2, or we sometimes just call that a half of the plyboard. If we have that same plyboard, but instead of drawing a line across like that, let's draw a line coming straight down. And now I still have two parts, two equal parts. If I paint this side over here yellow, then I have painted one out of two parts yellow, or I have painted one half of the plyboard in yellow. Or if I have 8 stars like this, that's the total number of stars I have. So I have 8 stars like that, and I paint that one there, and this one here, and this one here, and this one here. I paint those 4 in green, then I have now painted 4 out of the 8 stars in green, 4 out of 8. Of course, we can reduce 4 out of 8 to 2 out of 4, and that carries us down to 1 out of 2. In effect, I have painted exactly one half of the original stars green. Now, coming back to that plyboard, I could have drawn a line like that and still divide it into 2 equal halves, well, into 2 equal parts. If I paint that part on the top here, then I would have painted 1 out of 2, which is I would have painted half. We say half, but actually it's 1 half of the plyboard blue. Let's take that same plyboard and divide it now into 4 equal parts. So the denominator will be 4. It would be whatever out of 4. If I paint 1 part blue, that will be 1 out of 4, which we know better as a quarter. If we take that same plyboard and we divide it into 4, and we paint this one here one color, and we paint that part there, and we paint this part here. Now you can see that we have painted 3 parts out of 4. So the painted part here would be 3 out of 4, or 3 quarters. And this is what we mean by a fraction. Or if we have 8 stars like we have here, so it's 8 stars, and I paint 1, 2, 3, 4, 5 of them green, then I have painted 5 out of the original 8 stars green. So 5/8 of this total number of stars is now painted green. Let's consider that same plyboard, and this time we will divide it like that. I now have 8 equal parts, but then I divide each of those into 2, and I now have 16 equal parts. So my denominator will be 16. If I pick some of these, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, then what I have painted blue is 11/16 of the plyboard. And the parts don't have to be next to each other. It could be like this. So we have 16 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I am still picking 11 equal parts out of 16 equal parts. So now, even though the blue painting section on the one on the right looks different from the one on the left, it is still 11 out of 16. If you find this video useful and interesting, please like and share. Like and share. And you may also consider subscribing to this channel. It doesn't cost you anything, and it means a lot to me. Format of fractions, we already saw one number over another, like 1 over 2. Now, this format, as you learned previously, is called a vulgar fraction. That format where you have one digit over another one. There is also something called a decimal fraction that looks like this. And there is also something called a percentage fraction that looks like that. Normally, when we think of or speak about fractions, we mean the vulgar fraction format, this one. So, we will use the term fraction to mean vulgar fraction. So if we say fraction, we mean this format. If we say decimal, we mean this, even though that is a decimal fraction. And when we say percentage, we mean this kind of format, even though that is also a type of fraction. So consider 3/16, 5/8, 10, 15, a quarter, 7/8, 12/20, 3/7. In all of the fractions above, you will notice that the numerators are less than the denominators. 3 is less than 16, 10 is less than 15, and so on. Such fractions are called proper fractions. They are still written in the common fraction format, as you see here. However, now consider the fractions above. 3/16, 5/9, 10/15, 5/4, 7/8, 12/20, 3/7. You will notice that they are not all proper fractions, even though they are all written in the common fraction format. And so you notice there is a problem here with that 5/4. This improper fraction now creates a dilemma that needs to be explained, since we said fractions are part of a whole. So we have a problem here at 5/4. This one is called an improper fraction. If you divide a cake into 4 equal parts, can you take 5 such equal parts and give them to your friends? Well, if you say yes, where did the other part come from? Obviously, it came from another identical cake cut in identical pieces, which means that we are dealing with at least 2 identical cakes. So we are kind of cheating a little in our definition if we are going to include improper fraction in what is a fraction. So let's consider that cake again. You cut that into 4. So you give one friend quarter of it, another friend, so now you finish with half of the cake, another friend, another quarter, so 3/4 is gone, another friend, the last quarter here. So 4/4 of the cake is gone, the whole cake is gone. So we take another similar cake, cut it in identical parts, and give this last part here to the 5th friend, who gets the same share like everybody else. And if we add this 4/4 to this 1/4, if we add those, we now get 5/4. So that an improper fraction means that we are dealing with more than one item. In this case, 2 cakes. It also means that the 2 items are identical to each other and that each is divided in the same number of identical pieces or parts. Any improper fraction can be easily converted into what is known as a mixed number, which consists of a whole number part and a proper fraction part. We simply divide the numerator by the denominator to get the whole number part, and then put the remainder over the denominator to get the proper fraction part. For example, this 5/4. If we say 4 into 5, we get 1. What remains from that 5 is 1. So you put that 1 over the 4 that we were dividing by, and you get 1 1/4, as we can see up here. A complete cake plus a quarter of an identical cake. If we say 8/5, we divide the 8 by 5, 5 into 8, 5 ones 5, 3 remainder, that 3 goes over the 5, and so 5/8 is the same as 1 complete item plus 3/5 of another identical item. If we say 14/4, again we divide the 14 by the 4, and we get 4 3s 12, remainder 2 over 4. We can reduce this, and so we get 3 and a half. So 14 over 4 represents 3 complete items plus 1/2 of another identical item. Now that we know what are proper fractions, what are improper fractions, and how to convert an improper fraction to a mixed number, we need to know one more thing in order to add and subtract fractions or mixed numbers. Well, actually, two things. But this one is most crucial. We need to know about LCM. What does LCM stand for? Lowest common multiple of a group of numbers. So suppose you need to find the LCM of 4, 5, and 6. Assume that these are denominators of three proper fractions. In order to add them, you need to find their LCM. If you look at the multiples of 4 from the lowest, we get 4, 8, 12, 16, and so on, right up to 60, 64, 68, and so on. Then we look at the lowest common multiples of 5. We get 5, 10, 15, 20, and so on. We could go up to 70. And we looked at the lowest common multiples of 6. We get 6, 1, 6, 6, 2 is 12, 6, 3 is 18, 6, 4 is 24, right up to 72 and further. Now, when you look at all of these numbers, we want to find the lowest number of these numbers that we see here that 4, 5, and 6 can divide without a remainder. And when we do that, we find it is 60. That's 60 there, this 60 here, this 60 here. That is the lowest common multiple that 5 can divide, 4 can divide, 6 can divide without a remainder. Okay, don't get worried. There is an easier way to find LCM. So let's do back that same question. We want to find the LCM of 4, 5, and 6. So you write down 4, 5, and 6 like that in a row, and you start dividing by the lowest prime number if it can divide any one of these numbers. So we will start with 2. Can 2 divide anything here? Yes. So we take 2, 2 into 4, we get 2. 2 can divide 5, so we bring it down. 2 can divide 6, so we get 3. Can 2 divide anything again? Yes. 2 into 2, 1. 2 into 5, we bring that down because it cannot divide it without a remainder, nor can it divide 3. We bring 3. Now, once we get this one here, we forget that column. We will concentrate on the others that don't have 1 in them. So, what's the next higher prime number? It is 3. Can 3 divide anything here? Yes. So 3 cannot divide 5, so you bring down the 5, but 3 can divide 3, and we get 1. So we will forget this column now. So we only have one more digit to deal with. And of course, after 3, the next prime number is 5. Can 5 divide that? Yes. 5 into 5, 1. Now that we have that, we will ignore everything here, and we will concentrate on these numbers that we use to divide. We will just multiply all those divisors. So we multiply 2 by 2 by 3 by 5, and we get 60. Now, this is a much easier way to find LCM of these numbers than what I did in the previous slide. So the LCM of 4, 5, and 6 is 60. Now, what that means is that this is the lowest number that can be divided by 4, 5, and 6 without a remainder. 60. Let's try another one. Suppose you need to find the LCM of 4, 5, and 8 this time. So you set down the numbers like that, 4, 5, and 8. Can 2 divide anything here? Yes. So 2 can divide 4, you get 2. It can divide 5, bring that down. 2 can divide 8, you get 4, bring that down. Can 2 divide anything here? Yes. 2 into 2, 1. 2 into 5, bring down the 5. 2 into 4, 2. Can we try 2 again? Yes. 2 into 5 can't go. Just bring it down. 2 into 2, 1. So now, remember, once we get this 1, we ignore that column. Once we get this 1, we ignore that column. But we still have a 5 here. So 5 can go into 5, 5 into 5, 1. And now we ignore everything here and concentrate on these numbers that we use to divide. Multiply all the divisors, 2 by 2 by 2 by 5, and we get 40. So the LCM of 4, 5, and 8 is 40. That means that the lowest number that can be divided by 4, 5, and 8 without a remainder is 40. Let's try one more. 5, 6, and 8. We want to find the LCM of these. Again, we set down the three numbers, or however many numbers, 2, 4. However many numbers we have, we set them down like this. And then we start looking to divide by the lowest prime number, which in this case is 2. Can 2 divide anything here? Yes. Well, 2 can divide a 5, so we bring it down. 2 can divide that 6, so we get 3. 2 can divide that 8, so we get 4. Can we try 2 again? Yes. So 2 cannot divide that 5, bring it down. 2 cannot divide that 3, bring it down. But 2 can divide this 4, and we get 2. Can we try 2 again? Yes. Bring down that 5, bring down that 3. 2 into 2, 1. Now, once we get this 1 here, we will ignore that column. So now we concentrate on this 5 and this 3. You have seen this before. What is the next higher prime number? 3. Can 3 divide anything here? Yes. So 3 into 5 can't go, but 3 into 3 is 1. So now we will ignore that once we get this 1 here. And so we only have 5, so we try 5 into 5, 1. And so we ignore everything on the right here, and we multiply these divisors. We just multiply them, which will be 2 times 2 times 2 times 3 times 5. You could multiply in any order. We get 120. So the LCM of 5, 6, and 8 is 120. That means that the lowest number that can be divided by 5 and 6 and 8 without a remainder is 120. One other thing before we add, subtract, multiply, and divide fractions, something called equivalent fractions. Now, this is not as difficult as it sounds. Now, these are fractions that have different numerators and denominators, but are equal to the same ultimate value. For example, consider this fraction here. We know of another fraction that is equivalent to that, which is 2 over 4. 2 over 4 is the same as half. And furthermore, 9 over 18. In other words, if you reduce the 2 over 4, you will eventually come to that half. And if you reduce the 9 over 18, you will eventually come to the same thing. So all of these that you see here are equivalent fractions. They are the same fraction written different ways. Let's consider 4/5. 12 over 15 is the same as 4/5 written differently, or 40 over 50, or 48 over 60. All of these are equivalent fractions. To reduce a fraction to its lowest form, we divide both the numerator and the denominator by the same prime number, increasing prime numbers as required, as we were doing for LCM, until either the numerator or the denominator becomes a prime number itself, at which point you stop. So let's take one example. Let's take this 48 over 60. If we divide that by 2, we get 24 over 30. If we divide that by 2, we get 12 over 15. Now, obviously, we can't continue dividing by 2 because 2, while it can divide 12, cannot divide 15. So we will try 3. So 3 into 12, 4. 3 into 15, 5. At this point, while you can reduce 4 further by dividing by 2, you cannot reduce 5 by dividing by 2. Nor could you find a prime number that can divide both of those. So this number now is a prime number. We stop, and that is the lowest we can carry, 48 over 60. So for this video, we were looking at part A of objective 3 in section 1. Well, part 3A, we just looked at concepts relating to fractions. And then in the next video, we will actually be adding, subtracting, multiplying, and dividing fractions. So we just consider some prerequisite for this objective here. Now let's add and subtract fractions and multiply and divide. So this is what we did. And that brings us to the end of video 3A of objective 3 in section 1.